All right, hello there, Algebra 1 CP. This is our first video lesson for Group A. Group B had a video lesson the other day. But of course, no matter what group you're in, you can always feel free to come back and go watch the video if you need a little bit of extra help. Today, what I'd really like to do with you is continue our conversation on solving equations, but also focus more on equations that have a couple more steps to them. They're not just like the quick 1 and 2 step equations. Maybe it requires 3 steps or maybe even 4 steps and a little bit of distribution. So I want to show you a bunch of examples like that. A little reminder is please make sure you try the practice problems that are attached on Google Classroom at the end of watching this video. They are not required to hand in, it's not mandatory, but I think it's just to your benefit to try those practice problems. And if you want me to provide some feedback on those, I'd be happy to do that for you. Just send me a picture of your work via email or something, and I'd be able to respond to you. All right, without any further ado, let's go ahead and jump right in. I want to start with a problem that we did last class just to sort of review it. So as a little recap, if I have a problem like this and I'm trying to solve for k, looks like this. We got k divided by 3 minus 5 is equal to negative 9. And I'm trying to solve for k, right? Well, what I want to do in a problem like this is first, eventually I want to get down to k equals. So first what I want to do is isolate or get this k by itself, isolate the k. In order to even start to tackle this term here, this piece, I need to get rid of this minus 5 that's attached to it, right? How can I do that? Well, I can add 5 strategically to eliminate the minus 5. But if I add 5 on the left-hand side of the equation, I need to do the same on the right-hand side of the equation. I'm going to add 5 there. That gives me k divided by 3 is equal to negative 4. And again, don't freak out because you see something that looks like a fraction. K over 3, or k divided by 3, I'm just going to multiply by 3 on both sides. And the logic of doing that, again, is because how can I eliminate dividing by 3? Well, I'm going to do the operation that corresponds with division, and that's multiplication. The inverse of division, the opposite operation, is multiplication. So multiply by 3 on this side gets us down to just k equals. And over here I get negative 4 times 3, negative 12. So my solution is k equals negative 12. And you could always go back and check your work if you need to. If you take negative 12 and plug it in for k, negative 12 divided by 3 is negative 4. Minus 5 gets us to our negative 9, so we can be sure that our work was accurate. Any questions about that at all? Seems like we're pretty A-okay with that. Now, what if our equation has a couple more steps in it, though? Namely, some distribution. How about a problem like this? Let's do solve for x. We'll do negative 15 is equal to 3 times x plus 1. Ooh, tricky stuff, right? Well, hopefully you recall something called the distributive property in other math classes that you've taken previously. And what that means is if I want to do 3 times x plus 1, the whole quantity of x plus 1, I can take this 3 and distribute that multiplication through. You can say that this is equivalent to negative 15 is equal to 3x, 3 times x, and 3 times 1, so plus 3. Okay? You do 3 times x here and 3 times 1 here, and this comes out to be the same thing. All right? If you don't believe me, check the distributive property with like normal numbers. If I did like 3 times 4 plus 5, right? You could do 4 plus 5 first and get 9. 9 times 3 is 27. Or you could do 3 times 4 is 12. Plus 3 times 5 is 15. 12 plus 15 is still 27, right? So it checks out, even with regular old integers. But anyway, going back to this problem here, in order to now solve for x, we can do exactly what we did over here. Let's get this 3x by itself by first moving this 3 over here. It's like subtracting 3 from both sides, and that subtraction of 3 from both sides will bring us to negative 18 on the left and 3x on the right. Again, we subtract 3 because we're eliminating this term of 3 here. And lastly, I can divide both sides by 3 to undo the multiplication by 3, doing the opposite operation, the inverse. And that gets me that x is equal to negative 6. Or really, if I want to write it in, to be consistent, you would say negative 6 is equal to x because x stays on the right. But some people feel a little more comfortable always putting x on the left. Whatever you choose to do is absolutely fine. You're saying the same piece of information. And if you take negative 6, go plug it back in and check your work. You would do negative 6 plus 1, which is negative 5. Remember order of operations. And then 3 times negative 5 gets you to your negative 15. Okay? You could also take that negative 6 and plug it into this step as well, because this step is equivalent to this step. 3 times negative 6 is negative 18, plus 3 is negative 15. Questions on that? Let's do another distribution example. Suppose I want to solve for, we'll use a different letter this time, C. Okay. Suppose I have negative 6 is equal to negative 2 times C minus 5. This can be a little trickier than it seems because I'm distributing this time, but I am distributing a negative 2. And you don't want to forget that. When you distribute a negative 2, the negative goes with it, so to speak. You're distributing the whole quantity of negative 2. Negative 2 times C, negative 2 times negative 5. So this is going to become negative 6 on the left side. We haven't touched that yet. Is equal to negative 2C. That's negative 2 times C is negative 2C. Negative 2 times negative 5, positive 10. So plus 10. Now I can go ahead and just solve it like my normal two-step equations from up there. I need to get this by itself first, so I'm going to subtract the 10 over to this side. That gives me negative 16 is equal to negative 2C. And last but most certainly not least, I want to undo this multiplication of multiplying by 2. So I divide by 2 on both sides, or negative 2 rather. I almost made the same mistake that I was just about to say not to make. Don't forget that because this is negative 2 times C, you want to divide by negative 2. You don't want to just divide by 2 because then you have the lingering negative still sitting there, right? Divide both sides by negative 2. You're left with negative 16 divided by negative 2 is positive 8 is equal to C. Okay? That's a very common mistake. I misspoke. I almost made that mistake where we do negative 2C. You want to divide both sides by negative 2 because you need to get rid of that negative as well on both sides. Okay? Cool. So there's a couple examples with distribution. How about a little multi-step problem like this? What if I said solve for x? Okay. Underline these. Solve for x, right? We have 2x plus 11 divided by 7 is equal to 3. Ooh, little tricky. There's a lot of steps going on here, right? So I would love to get to this 2x, right? Because it has the x in it. I eventually want to get x equals, but I at least want to get down to this 2x, right? Well, what's tough right now is not only do we have this annoying plus 11 over here in the way of my 2x, I also have this big division by 7. So before I even approach the numerator of this fraction, the top, I need to get rid of this division by 7 because that division by 7 is like blocking in all of this top stuff, right, from being touched. So what I want to do is multiply by 7 on both sides strategically because that will get rid of division by 7. That gives me now 2x plus 11 is equal to 3 times 7, which is 21. Hopefully you noticed that when we multiplied by 7 on this side, we didn't actually have to change the numerators here because the whole thing was over 7. So because this whole thing was over 7, multiplying by 7 undoes it or cancels it out, so to speak. Now I can solve it just like my two steps from before. I'm going to isolate the 2x by subtracting 11 from both sides. Gives me 2x equals 10. And lastly, I'm going to choose to divide by 2 on both sides to get rid of the 2 here. And we have to do it on the right side too. You can't just touch one side of the equation and not the other. You get x equals 5. Once again, if you want to check just to make sure that this works, I should have done this over here. We can take 5, plug it in. Order of operations, multiply. 2 times 5 is 10. Add to the 11. 10 plus 11 is 21. And divide by 7, you'll get the original 3 that you started out with. Okay? Over here, this previous problem, if I take the 8 and plug it in, we get 8 minus 5 is 3. Negative 2 times 3 is negative 6. Questions, comments, concerns? It's hopefully sinking in a little bit. Let me show you another problem like this. And then we'll do a couple others that involve some distribution and something called combining like terms. But we'll get there. Okay? How about if I have solve for, we'll do y this time. 13y minus 4 divided by 11 is equal to 2. And I want you to solve for y. Well, we're going to kind of do the same steps that we just did over here, in the sense that before I can even access this entire numerator, this entire top section, I need to eliminate this denominator, the bottom section. I can do that by, since this is all being divided by 11, I can multiply by 11 on the left, which would eliminate that. But again, I can't just touch the left and leave the right alone. I have to do that to preserve equality. It gets me down to 13y minus 4 is equal to 2 times 11, which is 22. From there, I can get the 13y by itself, add 4 to this side, add 4. The add 4 is going to cancel out the minus 4. Gets me now to 13y, which is equal to 22 plus 4 is 26. And last but most certainly not least, I can divide by 13 to undo that multiplication there. Divide by 13 on the right as well. We get down to y equals 2. Okay. You can check your work, by the way, by taking 2, plug it in, and see if it works out. If 2 goes in, I'm going to do 13 times 2, which is 26. Minus 4 is 22. Divided by 11 is 2. So that works out just fine. Alrighty. Let me show you a couple examples now of something that's known as combining like terms. And I'm pretty sure this is something that you've been exposed to before, but if not, I'll try to explain it as best I can. All right. Suppose you had a problem that was like this. We wanted to solve for x. Okay? And let's say we have x plus 3x minus 1 plus 4 equals negative 5. Okay, something like that. Well, what you're probably noticing is that there's a lot of pieces to this. We have an x, we have a 3x, we have a negative 1, we have a 4, and on the right, all by its lonesome, we have a negative 5. What we can do, and what we're allowed to do, is combine terms that are like, they're referred to as like, or the same, in the sense that if I have 1x and then I add on 3 additional x's, well, how many x's do I have in total? I had 1, I now have 3 more. We can combine x plus 3x to say, well, that's just 4x. Does that make sense why that's the case? X plus 3x is 4x because we had 1x, now we have 3 more. There's a total of 4 x's. We can do the same over here. I have negative 1 plus 4. Negative 1 plus 4. Why not just simplify that to positive 3? Like, why leave it separated? That would just make it more complicated. And now a problem that looked like it was scary just like 30 seconds ago, now all of a sudden is like, oh, that's just a 2-step equation again. We've done 2-step equations. I can isolate the 4x by first subtracting 3. Gives me 4x is equal to negative 8. Divide both sides by the 4. Hopefully you're understanding now why we divide by 4 to undo the multiply by 4. I get x is equal to negative 2. Again, the question is, does that work out? You could take negative 2 and plug it back in. Even if we plug it into the top, you're going to get negative 2 plus 3 times negative 2, so negative 6, minus 1 plus 4. Negative 2 plus negative 6 is negative 8, minus 1 is negative 9, plus 4, bam, negative 5, just like we thought it would be. Does that make sense to everybody? Hopefully we're making good progress here. Okay, what if we really crank up the dial? This is the last problem we're going to do. Ready? Are you ready for this? I'm excited. I've been looking at this problem all day. It's been on the sheet of paper next to me. I'm like, oh man, here we go. Here we go. Now we're getting serious. Solve for x. If I have this, negative 18 is equal to 7 times x plus 5 plus 8 times 4x plus 8. Oh boy. Oh boy. Doesn't that get your blood pumping? You're like, wow, look at that. I can't wait to apply my mathematical knowledge to solve that. You don't think that way? Maybe it's just me. Anyway, just because I'm a big math nerd. If I go into this, right, what I want to do first, hopefully it's jumping out to you, that I can distribute. Not just once, but twice here, right? Because on the left side, I'll be left with negative 18. On the right side, I can do 7 times x, 7x, 7 times 5, 35, plus, do distributing over here as well. 8 times 4, 32x, right? 8 times 4x, 32x. 8 times 8 plus 64. Now, even though the terms are not adjacent to each other, and that's really a strong point that I want to bring up, even though the terms are not next to each other, they're still on the same side of the equal sign. And because everything is on the same side of the equal sign, right? Remember I talked about this equal sign being like a wall? I'm just modeling it with the pen there. If we're on the same side of the equal sign, we can combine them together. A common mistake that a lot of students will do is they'll look at something like this and they'll say, ooh, I have a plus 35. I know I want to get rid of that 35, so I'm going to do minus 35, minus 35. Bad, bad, bad news. If I subtract 35 from one side of the equal sign, which I'm certainly allowed to do, I need to subtract it from the other side of the equal sign, right? The other side of this equal sign. Not just in a random spot because I feel like it and because I notice something that might match up with it. I need to subtract it from over here, okay? So please, 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 another thing people might do, yeah, like move stuff around, like subtract 64 and do minus 64. Bad news, bad news, bad news. We need to, if you do something on one side of the equal sign, it needs to be done again, but it needs to be done again on the other side of the equal sign, not just somewhere else randomly. All right, so that's an important point I wanted to bring up. But before you start to move terms around, what I would do is I would try to combine what can be combined on this side of the equal sign. If you notice, we have 7 x's, and then we have 32 more x's all on the same side of the equal sign. So let's combine those together to say in total, we have 39 x's on this side of the equal sign. And we have 35 and 64 both on the same side of the equal sign. So let's stick them together and say we have, what is this, 99. Okay? Now that we have that, now, even though the numbers are maybe a little bigger than we've seen in previous problems, it's now just a two-step equation where I can say, let's subtract 99, because that would allow us to get to the 39x, which means I have to do it over here as well, right? So that eliminates the 99 over there. I get, sorry, I had to bust out the calculator. It's late in the day. Jeepers crow. We get negative 18 minus 99. We get negative 117. I should have been able to do that in my head. I apologize. Is equal to 39x. Now I want to go ahead and get rid of that 39 in front. We can divide by 39, right? Because that's going to undo the multiplication. This will go away. We have to do it on the left side as well. Just to save you the calculator work, negative 117 divided by 39 is negative 3. Is equal to x. Bingo, we are donezo. And if you prefer, again, you can sort of switch this around to say x equals negative 3 instead of negative 3 equals x. But either way, you arrive at the same conclusion. If you really want to check your work, you certainly can. Take this and plug it back in up here. Watch the order of operations. We're going to do this. Parentheses first. If I take negative 3 and plug it in, negative 3 plus 5 is 2. 7 times 2 is 14 from that whole first piece. Over here, negative 3 times 4 is negative 12. Negative 12 plus 8 is negative 4 times 8 is negative 32. And what is 14 minus 32? That's going to get you negative 18. Okay? So that works out just fine. You certainly don't have to double check your work, but I would recommend it, especially if you're taking any sort of assessment and you have extra time to do so. All right? So just a last little recap of what we did. We first started by reviewing equations that we've done already, just a two-step equation like this, where first we have to isolate by adding 5 and multiplying by 3 second. Then I said, well, what if now we're going to mix in some distribution, where I have to distribute this 3 here and here before we get our two-step equation? Still not too bad. We can do that, right? We're used to doing that from 8th grade or even earlier. Here, same deal. We've remembered to distribute the negative That's like a #1 source of student mistake. Please don't do that. Please don't make that error. Here, I notice the whole quantity is being divided by 7, so I can multiply on both sides to get down to a familiar form as well. Same thing with this problem here. And then lastly, we saw that if you have like terms on the same side of the equal sign, we can combine them together. Notice for this problem, I didn't throw the -5 in with this -1 and 4, because you might be like, well, why didn't you just combine all the terms? Well, because it's on the other side of the wall, right? The equal sign is like a wall. We don't cross the streams, right? We don't go and combine all these things just because. We can't. These combine together because they're over here on this side of the equal sign. This, unfortunately, has to sit by itself for now. Okay? We saw that same thing happen down here. I didn't do -18 plus 35 plus 64 and condense it all down to one thing because the -18 is on its own side of that equal sign barrier. Alrighty, hopefully that made a little bit of sense. What I would recommend is please try those practice problems that are attached with this video if you can. It will just help reinforce the concept. It's just for your benefit. But other than that, hopefully that made sense. I hope you have a fantastic day, and I will see you soon. I'm recording this on Tuesday, so for A group that has to watch it, I'll see you on Thursday. And if you're watching it in the B group, then I'll see you soon. And if you're watching it just because you want to watch some math, then good for you. And I wish you the best of luck, and I hope you have a fantastic day. Thanks, everyone. Take care.